Hello, everyone. Brian here from Flow. And today we're going to do a new version of Hello World that highlights some of the unique and special features of Flow, particularly resources and the move operator. Resources are a special type found in Cadence that are very similar to structs with one interesting and special difference. They can only exist in one place at one time, and you can only use them once. Looking real quick at our resources page, you can see an example here of resources and the move operator, which is this fun little arrow right here. In it, we have a definition for a simple resource. Again, this looks quite a bit like a struct. We've got the resource keyword, a name for it, and a property and initializing that property, very similar to how we initialized contract level variables in the last tutorial. And here we have let a, which is a constant of the type of some resource. And you know it's a resource because it has the @ symbol in front of it. And we are creating some resource and initializing it with a value of 5 using the init function, which calls for an int of value. And after creating it, we're moving it. And you really should think of it as actually moving the data into the constant called a. Now we create a new constant called b, and we move a from the location in A to the location in B. Having done this, you'll now get an error if you try to use a.value because A doesn't exist anymore. A is empty and discarded because the content of it was moved from one place to another. In the blockchain space, this is a really neat idea because it means digital property that you own can only exist in one place, and it's much harder to accidentally duplicate it. And the language has rules built into it to make it so that you can't accidentally delete it or forget about it or discard it. You must explicitly move it somewhere where it can be or explicitly destroy it in your code to prevent accidents where you burn something that you didn't mean to burn that might be yours or someone else's very valuable digital property. And that might sound like a few more steps to complete anything, and you're right. But doing so makes it nearly impossible to accidentally duplicate, break, or burn an asset. So after completing this tutorial, you'll be able to instantiate a resource in a smart contract with the create keyword, save, move, and load resources using the account storage API and move operator, use borrow to access and use a function of a resource, use the prepare phase of a transaction to load resources from account storage, set and use variables both in the prepare and execute phase. And finally, you'll use a neat shortcut called the Nil Coalescing Operator to panic when a resource isn't found. So again, a resource is a lot like a struct. You declare a format, a structure for how you want data to be stored and potentially add functions to manipulate or view it. In this example, we're creating a resource that anyone can access called money. And it's important to note here that in this case, access all does not mean accessing your money or someone's money. It means that anyone can access this type that we've created, which is useful because if you create a new format of money, you want other apps and other contracts to be able to use your new money construct in their applications because that's good for you too. It's all a part of composability. And we have a resource level constant called balance, which is initialized, in this case, as 0. So not the best kind of money if you never get any, but it's just a simple example. Let's click to open up the playground, and you can see we've stubbed out a contract for you. The first thing we'll do here is we'll define our resource type. And like I said, access all means that anyone has access to the type definition and can use the type in their own contracts and own apps. Resource keyword, because this is a resource, and we'll call it HelloAsset. And in it, we'll just add one function, a view function that says access all view, again, meaning it can look at contract state, but it cannot change it. And if you're coming here from Solidity, you'll find that the pure and view keywords are combined in Cadence, and we just have one for functions that either view state or do calculations and computation without viewing any state. Call the function hello, and it will return a type of string. And in this case, we're just going to return hello resources. Now, an interesting thing to note here is that this function is not present in the contract itself, and it can't be called directly. Instead, it's present in the definition of a type, and we would need an instance of that type to reference to call this function. Again, this should be pretty similar to classes or structs in other programming languages. languages. So to be able to use this, we'll need to add a function at the contract level that creates and returns a resource. Be careful that you don't put this in your resource. That would be self-referential and won't work. So down here at the contract level, we want this to be public. So access all, function, create HelloAsset. And this is going to return a type of the resource. And in Cadence, resources are special, so we mark them with the @ symbol. So anyone who's looking at your contract can see at a glance that this type that you've created is a resource. HelloAsset. And this is going to be a dense line right here. We're going to return, and we have to use the move operator to move our new resource out of this function and through the return. And that will actually place the data into the transaction that calls it. And we'll have to explicitly handle it within that transaction. And then we use the create keyword to create a HelloAsset. And you create resources by using this keyword and then calling the name of the type like it was a function. And we don't have an initializer for this resource, but if we did, we could put the arguments in here, similar to, again, creating a struct or a class in many other languages. So we're done with this contract, and we can deploy it by clicking the deploy button and waiting for it to go through. And we can see that it's here. We'll double check. We've got our deployed contract. It's spelled correctly this time. And now we're ready to interact with it. So we've got two transactions here, create hello and load hello. So next we'll work in create hello. We've stubbed it out for you so you don't have to import the contract on your own. And what this transaction needs to do is it needs to do two things. And it's a little more complex than it might seem on the surface, because we need to call our function in our smart contract to create a resource. But now we've got a piece of digital property that we have to do something with. We have to find a new home for it, or I guess since it's just created, the first home for it, but we have to explicitly put it somewhere. And in this case, we'll put it in the calling user's storage so that they now own an instance of this resource. And it's a unique and individual instance of the resource that through Cadence, they own completely, and they can even transfer from one account to another without letting the contract author know about it. They actually own this. So the first thing we want to do is create our prepare phase. And in the prepare phase, automatically you get passed in a reference to the signer's account with the entitlements for that account that you ask for. Entitlements are another unique thing to Cadence that we'll learn more about soon. But the simplest way to think about it is it lets you create a vast amount of locks and keys to these resources and functions and anything else in your smart contracts that's very, very granular and specific and precise. So for something like a resource that's a token vault that holds your fungible tokens, you can grant one account to access to withdraw a certain amount of tokens, all accounts access to deposit tokens, because hey, if someone wants to give you money, why argue? And you could create some other functionality that different specific accounts can use. And then as the owner, you've got the skeleton key that can open up any of these locks and use any of this functionality automatically. But in a transaction in Cadence, you need to specifically ask for the entitlements that you need so that the signer of the transaction can see exactly what might happen. And then this is also used for wallet applications so that they can indicate to the user what might be happening. So here we're going to get our reference account and we're going to ask for authorization, save a value into that account, and we need account. So what this is it's a parameter called account, and it's going to have a type with this authorization for the resource of an account. And we use the and symbol when we're talking about an instance of a resource. So now we have an authorized reference to the user's account with the permissions that we need to save something to their account. So we can now call our function from the smart contract and let our new hello, our instance of that resource, and then we call the function the same as we did before. So hello resource dot create hello asset. And right away we get an error. And this isn't a bad thing. This is a good thing. The error is loss of resource, because right now we've created this new resource. We've created this new piece of digital property, but we haven't done anything with it. It doesn't go anywhere. So this code is not allowed to execute because we can tell from static analysis that this code would lead to the loss of someone's property. And you don't want that to happen unless you explicitly say, I am destroying them. So it's a great way to protect yourself from all kinds of really nasty, frightening bugs that you could otherwise write into your smart contracts that would cause things to get lost that people might have paid money for. So what we need to do is use the save function that's built into account storage. So accounts have storage, which we can access with .storage, and then they have a built-in function to save things to that storage. And the first argument here is the thing we're saving. And in this case, we are explicitly moving, using the move operator, new hello. And again, we're not copying the data. This isn't pass by reference or even pass by value. It is move the data from where it was before, destroy it, the old copy, and place the new copy in somewhere else. Or really, I like to think of it again, the name of the keyword is just move. Otherwise, you start getting into arguments about how teleportation works and what really happens to the old one of you and the new one of you. And no one wants to think about that. Or the second parameter is where it's going. And in this case, it's going to a path and account storage. And note that these paths are not strings. They are their own kind of type as well. And in this case, storage, which is a location that all accounts have, and it's where you store things. And we can give it whatever name we want here. And in this case, we'll say HelloAsset tutorial as a logical name that we can use to find this later. And notice now that the error for our loss of resource has been resolved. Now for this transaction, we don't really need the execute phase, but we might as well use it for something. It's good practice. So we'll log a message that says we've saved the resource to our account. And we'll learn soon about a better use of the execute phase. It is worth mentioning that the execute phase cannot access a reference to the user's account. And the reason for that is it allows us to statically analyze the areas and paths that the signer's account and a given transaction can modify. And then browsers and wallet applications can use this to show to users what a transaction can alter, take, destroy, or anything that the user wants to be careful about. So we'll execute this. We have account 6 as the signer, and we'll send. And actually, let's go ahead and execute it for account 7 as well. And now we can look and see that these accounts have that saved in account storage. And it's a little more buried in account 6 because we also have the contract information. The other thing to take note of is, again, Cadence protects you from accidentally destroying things. So if we call this function again, we'll get an error. The transaction has failed to execute because there is something already at this path. Account 7 already stores an object at this path. And we'll learn soon about a more elegant way to handle some of these scenarios. Actually, we'll do it right now. The first thing we'll need to do to check and see if a resource is already stored in that location is to update the entitlements that we're asking for to include the entitlement to borrow a value, which is called, appropriately, borrow value. Next, up at the transaction level, which is similar to contract level or class level, we'll add a string variable to store the result of our attempt to find out whether or not a result is there. So we'll say var for variable, result, and it's going to be a string. As with a class level variable or constant, we'll get an error here that we're missing the initialization of the field. For transactions, we don't have an init function. Instead, we initialize these fields inside of the prepare phase. And we're object-oriented, so we'll say self, referring to the transaction itself, dot result, and we'll initialize it as saved hello resource to account. And we'll also add a constant for the storage path. So we can say let storage path equal, and we can copy and paste our storage path to here, and then use that variable. And again, a reminder that storage paths are their own type. They are not strings and they do not have quotes. So one way to check if a storage path has an object in it is to use the built-in storage.check function with the type and the path. And note that we're saying both the type and the path, which means if it's true, that's indicating that there is an object in account storage at that path that matches that type. If it doesn't match that type, it'll return false. It doesn't mean that the location is empty if it returns false, just that the object doesn't match it. What this lets you do is to check for collisions and then handle them appropriately if another app or a malicious app uses that storage path. You can give the user the opportunity and the ability to check what's there and delete it if appropriate. So what we'll do is we'll say that if account.storage.check, and we're checking for a type of a resource. So we use an @ hello resource, our contract name, and then .HelloAsset resource type. And note that in this case, it's unhappy because we're not done typing yet, but the @ symbol goes at the beginning of the whole string because we're marking up front that, hey, at the end of this namespace path, we've got a resource. And then we provide the location from our storage path. So if something is here, we need to change our result message to self.result, and we are unable to save resource already present. Else, we can move this line up here and use that to create and move our resource, and then move up the line because we also need to, after we've moved it into our local variable, we need to move it into account storage so that it's safely saved there. And finally, we'll update our log. Instead of using the string here, we'll log the result. And again, object-oriented, so self.result is using the transaction level variable result that we declared up here. So now we can send this transaction again, and we get a nice error message. And again, this is optional depending on your app design. We're mostly just exercising how to use the check function. You do have a built-in error, so it's not absolutely critical that you do this. It depends on your app design and the scenarios that you're trying to cover. Finally, we need another transaction to load our resource into a transaction and use it to call the function that says hello world or hello resource. So we'll check out load hello. And here we can practice again importing our hello resource contract from OX06. And we're creating a transaction. It's not going to need any arguments, so we can skip the parentheses. And we'll start by preparing a transaction. And for this, for the entitlement, we need to borrow a value again from the account, or it's not from the account in this case, it's where this is the auth that we're getting in our account reference. So you just learned how to add the borrow value. So in create hello, we use borrow value to check for the resource. Now we're going to actually borrow the resource itself from the account. And borrow is a little bit of a tricky concept when we're talking about resources, because borrow is a reference. It's not moving the actual resource itself into the transaction. It's not taking the property from one place to another. Instead, it is a more conventional programming concept of borrowing a reference to something, which allows us to call the functions that are inside of it. Again, here, our goal isn't to take this resource from one address and give the resource to another address. Our goal is just to use something that is in the storage in this given account of the caller of the transaction. So in this case, we'll let our hello asset, and that will become account.storage using the built-in function .borrow to borrow a reference to the resource, but not the resource itself. Hello resource.hello asset, and we're borrowing that from the path of storage hello asset tutorial. And then what if this goes wrong? What if nothing is there? You know, we've already seen the case that that's possible. One way to do it is to use the check like we did before, but we can also do it in the middle of our borrow using what's called the Nil Coalescing Operator, which basically says if the thing on the left doesn't work, do the thing on the right. And here, and it's a double question mark, and the tutorial has a link to the docs that explains the full functionality of this feature. But here, we're going to use it to explicitly cause a panic. And we'll say panic. We can actually put the question marks down here too, so that they're a little more visible and we can see what's going on. And we want to raise a panic, which is, in other words, aborting the program with an error. And we'll say the signer does not have the hello asset resource stored in, and then we'll copy and paste the path here. So now, if we don't find the asset, the program will abort with an error that we can use to figure out what's wrong and guide the user, or have our app guide the user to fixing it. But otherwise, we have a reference to our resource. And it's very important here to remember, borrowing a reference does not allow you to move or destroy a resource, but it does allow you to mutate the data inside that resource if that resource's functions allow the mutation of the data and the caller has the appropriate entitlement to call that function. So any system can have a mistake. So the power of Cadence lets you give granular permissions to a user's or owner's resource to other users and owners or addresses. But if you give them that permission, a reference will allow them a borrowed reference will allow them to call those functions and potentially change what's inside the resource. So finally, now that we have our reference, we can use that reference to call the function. And here we'll just log in the prepare phase, HelloAsset, and then call the hello function. And that's it. And remember, the execute phase is optional, so we don't need to use that here. We can just send this transaction and we get in our log hello resources. But if we change the signer to signer 9, for example, who I have not created a resource for, and we call it again, and we get an error. We get a panic, and here's our message right here. The signer does not have the HelloAsset resource stored in the storage location. So again, to summarize, you've created your first resource, and you've instantiated it with the create keyword through a transaction. You've saved, moved, and loaded resources using the account storage API and the move operator. You've used borrow to access a function inside of a resource. You've used the prepare phase of a transaction to load resources from account storage. And you've set and used variables in both the prepare and execute phase. And finally, you've learned how to use the Nil Coalescing Operator to panic if a resource is not found. Thanks for watching, and see you in the next tutorial.